thank you for joining me on exercise 6E. I'm going to be looking specifically at question 2, part C. It says to complete the following table, and what we've got is we're going to need a calculator. Can I find a calculator here without... Can I find a calculator? It's not too difficult. Let's split the view. Let's get a calculator. Yeah, we've got a calculator. Can we make it a bit smaller? All right, that'll help. So we've got sine of theta, and so is 0.3907. We've got cos of theta, we don't know. We've told that tan of theta is negative 0.4245, and we're after what is theta. Well, I'm going to use the calculator because I have to. However, I'm not going to use it. I'm not going to rely on it. I want to share with you my tools that I use for this type of question. First tool I use is knowing, it's like a cast rule, C-A-S-T. It's knowing that all of the ratios are positive in quadrant 1. It's knowing that only sine ratios are positive in quadrant 2. It's knowing that only tan are positive in quadrant 3. And it's knowing that only cos is positive in quadrant 4. Second resource I use is, and I like to write it down just to get it ready, just for your benefit, is the rules. We always go to the x-axis, not the y-axis. So if you want the acute angle, work out what the angle is to the x-axis. And we can use these rules here to help us. Now that's if we're degrees, but it's good to know that we also have to deal with radians. So it could be pi minus theta in the second quadrant, pi plus theta will be a third quadrant, and 2 pi minus theta is the fourth quadrant. The other resource I use is knowing the triangle. And there are two types of triangles that we have, and that is the equilateral triangle and the square. The square is like using for 45 degrees or pi over 4, and it's a 1 by 1 square. The triangle is a 60 degrees, 60 degrees, 60, but it's a 2 by 2 triangle. And we split this up into a half to get a 90 degree here, and that would give us 30 degrees up here. And so the opposite side down here is 1 and 1. And then using Pythagoras, you would finally figure that that's root 3. You don't know how I did that. 1 squared plus b squared equals c squared. So 1 plus b squared has to equal 4. So b squared has to equal 3. Yes, b is root 3. Also, the hypotenuse here would be 2, square root of 2. Same reason. 1 squared plus 1 squared has to equal c squared. That's at 2 equals c squared. Therefore, c equals square root of 2. This is important to know because if we're dealing with 60 degrees or pi over 3, or if we're dealing with 30 degrees or pi over 6, or if we're dealing with 45 degrees, pi over 4, these are the triangles we use. However, sadly, all of that work, these are my resources, all right? Okay, this is important that you know that. But we won't be using, we have to use our calculator for this question because I don't recognize those decimals at all because it doesn't look like a root 3, which is 1.732, etc. So let's start. And we start here with our cast rule. Which quadrant is it? Well, we've got sine is positive, tan is negative. Straight away we know only sine is positive in quadrant 2. So straight away, if you're looking at this, you should be able to say that theta is a quadrant 2 angle. So we're dealing with an angle somewhere between 90 degrees and 180 degrees, or somewhere between pi and 2 pi. Just sorry, get that right. Somewhere between pi over 2, did you spot that? And pi. Okay, so that's where the angles are in that range. Well, it doesn't matter. We just now want the acute angle because we are going to be using, and I'll highlight this because this is an important concept. We're going to be using quadrant 2. I'll highlight. Let's use both degrees and radians. So we'll find the answer both in degrees and radians. So first, let's find the answer in degrees. So let's find theta, the acute theta, by just getting the inverse sine of the positive 0.3907. We don't use the negative. We just, for acute, we're actually focused on the first quadrant here and worry about the first. So let's get inverse sine. On our calculator, I need to second function this, and there you've got sine of over here. So you're going to have to look for inverse sine because I can't put it out. And I'm going to put 0.3907. I'm working on degrees, so let's hit the degree button so we get a little degree here. Now I'm going to press inverse sine. Therefore, theta is 23.0 degrees. That's to 3 significant figures. That's degrees. Or if you want radians, let's go to radians. Let's cancel that. Make radians up there. Okay. Now we go 0.3907. Hit inverse sine. And you get radians, which is 0.401 radians. However, that's just our acute angle. We can go straight away now, and therefore say in quadrant 2, theta is 180 minus 23.0 degrees. So the angle we're looking for is in fact 157.0 degrees. Just 157, that's 3 significant figures. Or to 1 decimal place, if we did degrees to 1 decimal place, we would put 0.0. It's always good to have 1 decimal place for degrees. Read the details to find out whether we need 3 significant or 1 decimal place. That's if it's degrees, but if you want radians, we would use the pi minus theta. Pi minus theta, which was 0.401. And just get that, I'll use approximately here. Use approximately because it's not exact. So pi minus 0.401 equals, and it's 2.74 radians, and that's 3 significant figures. Yes, that is a quadrant 2 angle, and yes, 157 is a quadrant 2 angle. Let's put our answer up here, or we use black. We'll put 2.74 radians, 2.74C, and I won't bother writing the 157 degrees up there. Cos, well, let's find cos of our acute angle, and we know it's going to be negative because it's quadrant 2, yes? So all we've got to do is put our acute angle. Okay, let's leave radians there. Because I've got a calculator, I'm going to go back to get my acute angle, which was it's all right, 2.74, we'll say 0.401. So radians, 0.401, that's good enough. Okay, and let's get the cos of that. 1 second, cos of that, and it's 0.921. Okay, let me just check that. I'm going to start using my calculator here. I'm going to go back to what we had to start with, which was 0.3, because we rounded off. I don't like using a rounded off number, and I used 0.401 in a calculation. So let's go back to 0.3907. We get this in degrees. Inverse sine, we got 22.99. That's the acute angle. Let's get a cos of that. And we get 0.9205. Yep, okay, 0.921 is good. Good to go. I hope this has helped. Until next time, stay happy. Well, before I wrap it up, I really want to just say one thing. Just notice that our cos is positive, our tan is negative, which is why we went to the second quadrant. Good? That's why we made sure that cos was negative. Then after that, we discovered our acute angle simply by going inverse sine of 0.9307. And we'll either operate with 23.0 degrees or 0.401 radians. Now, if you then want the number, you just press cos of 4.01, cos of 0.401, 0.401 in radians. If you just press cos of that, you'll get 0.920. And if you want tan of 0.401, 0.401 tan, you'd get 0.4. Well, we get a different number, but anyway, they've already locked that in, so I'm not going to worry about that. That's just error somehow for some reason, because that doesn't match. And why we said 2.74 radians, because we used pi minus theta, and we had pi minus 0.401. What? Okay, have a happy day.